Shankar, and I'm the director of the Energy Systems Engineering program here at Lehigh. And I have accompanying me is Susan Canarak, who's the coordinator for the program. And this is the last of our spring series, and it's such an honor for us to welcome two former graduates from the ESE program. And I can't think of a more fitting way to wrap up the spring seminar series. The title of the presentation is Voluntary Renewable Electricity Procurement, and it will be presented by Matt Croshal and Mike Sandford. And I'll read their bios, brief bios. Matt Croshal is a senior advisor for Edison Energy's Clean Energy Advisory Group. He's responsible for guiding C&I companies through renewable energy procurement, including development procurement strategies, educating key stakeholders and signatories, and leading procurement and contract negotiations. He has 14 years of experience in energy consumption and procurement, with a focus on sustainability and renewable energy. In his role as a consultant and advisor, he has advised on and negotiated 300 megawatts of renewable contracts and provided guidance on renewable energy to a wide range of Fortune 500 companies. Prior to his experience in corporate renewable procurement, he spent 11 years supporting federal entities with renewable energy and energy management strategy and implementation, actively supporting over $100 million in dollars in energy-focused capital projects. Matt has a BS in mechanical engineering and a master's in ESE from Lehigh University and an MBA from University of Colorado in Boulder. Mike Sandford is an associate director of Verizon's global real estate organization. His responsibilities included energy procurement, risk management, and sustainability strategy. He spent 4 years as a nuclear field energy engineer with GE Hitachi, where he led teams performing inspections and modifications of nuclear reactors around the world. In 7 years with Verizon, he has helped the company set corporate sustainability goals, including 100% renewable energy and carbon neutral targets. Mike has a BS in mechanical engineering and a master's in ESE from Lehigh and an MS in mechanical engineering and an MBA from MIT. Welcome, Matt and Croshal and Mike. Thank you.
Thanks, Rudy.
Thanks for having us.
Yeah. Well, welcome and happy Earth Day, everyone. Before we get going, just a little bit of admin to get out of the way. We are going to be talking about PPAs, which are swaps. Trio, which used to be Edison Energy, is registered with the NFA, National Futures Association, as commodity trading advisors. So as am I, meaning I am qualified to give you a balanced assessment of these vPPAs and give you a balanced assessment of the risks and benefits inherent to them. Mike?
And as part of any external engagements, we have to share this slide, which basically says that Verizon is a large publicly traded organization. And I will do my best to not say anything false. However, the measures included in this presentation should be, go back to official company documentation and please double check any financial statements made in this presentation. Thanks, man.
Yeah. All right, let's get right into it. So we'll probably buzz through introductions. Thank you, Rudy, for doing that. And then I want to talk about what the voluntary renewable market looks like, kind of what it is. I'll get into RECs, what they are, how they're traded, how they play in here. Mike will cover Verizon's energy and sustainability strategy, as well as on-site and local procurement options. And then I'll cap it off talking about off-site or virtual power purchase agreements. Rudy covered all this. 2 notes. One, I'm located in Denver, Colorado. And two, I did wrestle on the Lehigh wrestling team. So if there's any wrestlers on the call, congratulations, great job this year. Mike, anything to add?
Yeah, nothing to add. I was a classmate of Matt's for both undergrad and grad school, so it's good to be back 13 years later. It's been a long time. Yeah, so at my time at Verizon, I have focused on corporate energy strategy, as Rudy mentioned. But then on the real estate team, I've really been involved in renewable energy, EV charging, energy efficiency, environmental compliance, which is a new and growing area, and now most recently energy procurement. So all things energy and sustainability at Verizon. So thanks.
Yeah. All right, so why are we here today? What are we talking about? What is voluntary renewable procurement? So at a high level, when we're talking about voluntary renewables, we are talking about corporates and some nonprofits or NGOs who go out and set renewable targets voluntarily. Those targets may directly refer to renewable energy, such as we are going to be X% renewable by X year, or they might be a little indirect. We're going to reduce our emissions by X% by this target year. They're setting these goals voluntarily because they're getting pressure. Companies, corporates are getting pressure from their customers, investors, employees. And some of these companies do have values, and to not be too much of a cynic, sometimes they do follow those values. These goals, because they're voluntary, don't really have any strict rules or requirements. However, there are NGOs in place, non-governmental organizations, or essentially nonprofits, whose objective it is to help provide guidance to these companies in this voluntary space, help set up rules, put in kind of guidelines around procurement. And there are three big ones in this space. CDP, which used to be the Climate Disclosure Project, RE100, which is kind of the main body for 100% renewable energy goals, renewable electricity goals, and the Science-Based Target Initiative, or SBTI. And they are kind of focused on companies that want to reduce their emissions. Companies can make these goals public. You've probably seen companies with branding or commercials that say we will be offsetting our emissions, or we are doing this, or we are doing that. But some of these goals are actually kept private. Really, the goal here is for these companies to drive market action through their own behavior and leadership, and to make an environmental impact themselves. Important note here, this is a really new space. When Mike and I graduated, this really did not exist. I would say this started picking up steam in the mid-2010s and really kicked into high gear over the last few years. So as you're looking at what to do next when you're graduating, this is definitely a space that's growing. A lot is happening. Things we talk about today may not matter in 2 years or may look very different. So just wanted to flag that. So I mentioned direct goals, which are we're going to procure 100% renewable by X year, those kind of goals. There's also indirect goals. And just to make sure we're all on the same page, I want to talk a little bit about emissions. There's 3 types of emissions: Scope 1, Scope 2, Scope 3. Very generally speaking, Scope 1 emissions are emissions generated on site. For corporates, that's a lot of natural gas or fossil fuels that they're burning in furnaces, heaters, boilers, etc. Those are offset with carbon offsets, which is not something we're going to get into today. Scope 2 emissions are emissions generated offsite, consumed on-site. For corporates, that is almost all electricity. And those are offset using RECs or environmental attribute certificates, kind of 2 words for the same concept. And that's where we're going to focus today. You may also see Scope 3 goals, Scope 3 targets. Scope 3 is a much bigger bucket. It includes upstream and downstream emissions, upstream emissions being what was emitted to make the feedstock for your products, the parts for your products. Downstream, what is your product going to emit over its life? For car companies, that might be the fuel that those cars consume in their lifetime. Scope 3 also captures a lot of other things. Company travel, commuting, etc. It's a pretty big bucket. But we are going to skip that today as well and focus just on Scope 2 emissions and electricity. Some other concepts that are important in this space, outside of go meet your 100% targets, are right here on this slide. So I want to talk to them a little bit as well. Additionality is the biggest one. It's pretty established. It is pretty ubiquitous in this space as people talk about corporate renewables. But additionality is this concept that if this company or this voluntary participant did not take this action, these renewables would not be on the grid today. So that means going out and partnering with developers, putting renewables on your roof, actually taking action to bring new renewables onto the grid. This is a not well-defined term. That said, the market has kind of accepted a few concepts as including additionality. PPAs, power purchase agreements, which we'll talk about, on-site renewables, and mostly green tariffs, community solar as well. So there's a handful of things that just usually or almost always qualify. While this isn't required by any NGOs or any specific guidelines, it is really strongly encouraged. And for market leaders or large market participants, it's really expected. Going out and purchasing RECs and not providing additionality really opens companies up to greenwashing claims. The next one is 24/7 carbon-free energy or 24/7 time matching. When most companies set goals, they just want to make sure the units of electricity they consume throughout an entire year are matched with RECs of that exact same volume. So the time horizon is 1 year. What 24/7 energy starts to say is we need to make sure that every megawatt hour we consume, every unit of electricity we consume is matched with a renewable asset operating at the exact same time. Unfortunately, because wind and solar don't necessarily function at the same time that a company is operating, this is really challenging. You need the ability to curtail a lot, to adjust your operations a lot, and you need a lot of renewables. This isn't really widely accepted. It's happening in very small spaces, but it is a big topic of conversation, and a lot of the market leaders are trying to find out how to adopt this. This is also getting codified in some legislation. The IRA has some guidance around it for some tax credits, so it is gaining momentum. The last concept is emissionality. This is the concept that kind of throws RECs out the window, whereas when we're talking about RECs, a megawatt hour is a megawatt hour, it doesn't matter. Emissionality says we don't care about megawatt hours, we want to focus on matching emissions. And so if a company is operating in California that has a cleaner grid, they may want to deploy renewables instead of deploying them in California, maybe deploy them in Kentucky, which is a dirtier grid. Those solar panels are going to have a bigger impact and they're going to displace dirtier energy sources or electricity sources. And so emissionality is this concept that kind of takes a step back and tries to really look at what actual emissions are renewables offsetting and what emissions are we generating. It's, again, kind of out, it's more of a theory, it's more academic right now, but companies are starting to dig into it. It's valuable because it allows companies to actually more directly talk about the impact they're making, and it really does get into the weeds of what are you doing with when it comes to emissions. So yeah, three points that are going to probably become more and more important over the next couple of years. All right, so we've talked about the goals, what this space looks like, who the participants are, what they're doing. Now let's talk about how they're going to go out and do it. So RECs, how is renewable electricity tracked and traded globally and in the US? First, I want to take a quick step back. And I mentioned earlier, environmental attribute certificates or EACs. That is a global catch-all term for any sort of certificate that is meant to trade or track renewable electricity or kind of other environmental components to energy. In the US, for electricity, we use RECs, renewable energy certificates, or renewable energy credits. The way these work is because we can't track electrons, once a solar panel puts an electron on the grid, we can get into the physics of it all, but you cannot track it. You can't differentiate what electrons you are receiving from the grid. So instead, every time a megawatt hour is generated, a REC is minted at the same time. These RECs can be traded with the electricity, sold through retail providers or utilities. They can also be unbundled and sold independently. You can just go buy RECs separate from your electricity. The most important thing to take away from here is you need RECs to make renewable electricity claims. I have had clients who have solar panels on their roof and cannot take credit for the electricity coming off of them because they didn't retain the RECs. So even if the solar panels are on your roof, you still need those digital certificates to say, I used renewable electricity. And everything we talk about today is really just about different ways to get RECs and different ways to make those claims. I wanted to talk through this slide for two reasons. First, I mentioned EACs. You can see throughout the world, there are different kind of REC equivalents or other EACs. In Europe, you have guarantees of origin or GOs, Australia's LGCs, and Mexico's IREC. They're different all across the globe. The other reason is there are boundaries for these. Fortunately for us in the US, Canada and the US are considered one market. So you can generate a REC up in Alberta and retire it in Florida and vice versa. That's not always the case. A lot of the times, one country is the boundary, and you must generate and retire those RECs within that boundary. All right, two big items to talk through here. The first is unbundled RECs. So I mentioned you could go out, or companies can go out and just buy RECs in the open market. That is considered unbundled RECs. This market is a spot market, which means unlike gas or other commodities where you can pull up a website and look at the price, there is no kind of price tracking in a spot market. Anytime a company wants to buy RECs, they have to go out into the market and solicit pricing for whatever their volume is, for whatever their requirements are. This means it's a pretty opaque market, which means it's hard to forecast, hard to track. And while it is pretty easy to transact, there is some risk inherent there. The other piece I want to talk about is REC pricing. In the US and even in Canada, not all RECs are created equal. In states with our renewable portfolio standards or RPSs, you have compliance entities, all of the utilities in those states who need to buy up RECs in order to avoid fees or fines or kind of other compliance issues. And so you have other participants bidding up those RECs in value. So if you look at the chart on the right, Pennsylvania and Virginia both have RPSs. And so those utilities in those states are buying up RECs and raising up the prices. Unless a corporate has really specific goals or really specific objectives, they're usually going to transact when they're buying unbundled RECs with like Texas RECs or generic US RECs. These are RECs generated in states without RPSs. So the only buyers are going to be these voluntary participants, meaning the price is going to be pretty low because you have fewer restrictions, fewer lower demand. That doesn't mean it's without risk. If you go back 4 years, RECs were trading about $1 or less. Then in I think 2011 or 21, 22, prices spiked pretty significantly up to about $10. They have since settled unbundled RECs trade between $2 and $3 for the most part. So companies going out and making these transactions, these unbundled purchases to meet their goals, there are good reasons for it. Like I said, they're low cost. They're very flexible. You have to go out into the market and buy these at least once a year, if not multiple times a year, meaning as your load changes, you can change how much you buy. These are also they meet the rules. There is no rule saying you cannot use unbundled RECs to meet your objectives. So not a bad option. The downside, these are purely cost additive. There are situations in which you could do onsite and actually make money. Community solar sometimes provides savings. vPPAs even, at least historically, have been able to generate revenue for companies. These will always be cost additive. No one's going to pay you to take their RECs. It's also difficult to lock in long-term procurement. I mentioned the spot market, the opacity there. If companies do want to go secure maybe 10 years of credits, they're going to pay a significant premium. I mentioned RECs are trading between $2 and $3. Long-term strips can be north of $8 because developers and people who own those RECs don't want to give them away. They don't know what the price is going to be, and maybe there's a boon for them down the road. And probably the biggest hurdle here, these don't include additionality. When corporates go out and buy these, they do open themselves up to greenwashing claims. You may see companies in the news for not making an impact, et cetera, et cetera. Usually this is a big part of their strategy. It's kind of argued they're just paying their way out of it. That's kind of a philosophical conversation for another time. Before I hand it off to Mike, I want to talk about one more procurement option, which is green tariffs and utility green pricing programs. In regulated markets like here in Colorado, there may not be a ton of options for corporates if they want to do something local. So they kind of are forced to work with their utility. Green tariffs are going to be the more robust option here. you are literally moving your facility off of your rate structure onto a different rate structure that might have really unique cost, may have a unique cost structure. Usually there's a tenor to it. You have to be signed up for 3 to maybe 10 years. But the benefit is you are making more robust claims. You usually have line of sight to a single project. At times, they can actually be cost competitive depending on the structure. But they are challenging, right? You're signing up for a bunch of years. You've got to work with utility, which may not be straightforward. And usually there's limited availability. The other option through utilities is going to be green pricing programs. These are a much lighter touch. Here in Colorado, I can go onto Excel's website, click a box, and it will charge me an extra penny, and I get wind. The challenge here, these don't always include RECs. So a lot of times this is just a feel-good effort. It doesn't help corporates with their reporting. It's nice because it is a short-term commitment. You can usually opt in, opt out at will. But again, the downside, you're going to have kind of lower claims and you may not even receive RECs. The challenge with both of these is they're difficult to scale. Every utility across the country is going to have their own take on what they're offering, and you're completely dependent on what your utility offers. And so when a company has, let's say, 100 sites, it's really hard for them to guarantee every utility they're operating in offers this and that they're able to sign up. And even if they did, they would have to go sign 100 different contracts. So it can be a little bit of a burden, pretty challenging, but is a great local option for a lot of corporates. So with that, off to you, Mike.
All right, thanks, Matt. In my section here, first I'm going to talk about the types of renewable commitments that drive renewable procurement. Specifically, I'm going to take a look at Verizon's emissions and its strategy to meet its emissions and renewable energy goals. Let's see. There you go. Thank you. So the chart on the right breaks down Verizon's current emissions. And like Matt said, we have Scope 1, Scope 2, and Scope 3 emissions. Just to recap, Scope 1 are direct emissions from fossil fuel combustion on site. Scope 2 is the indirect emissions, largely from electricity. And combined Scopes 1 and 2 are considered operational emissions, those that we have very good control over. Scope 3, as Matt mentioned, is a big bucket of 15 subcategories of upstream and downstream emissions. He gave the example of an automaker. That's a good one. So it's like the steel, the emissions from the production of that steel going into the vehicle, and then the fuel that's burned downstream. So it's the total life cycle emissions of that product. And I would say it's typical for non-industrial corporations to have much higher Scopes 2 and then Scopes 3 emissions. So Scope 1 typically makes up a pretty small sliver. So I think Verizon's pretty typical here. With that in mind, I'll briefly mention how corporations can reduce each type of emission and then discuss examples of commitments to do so. So Scope 1 is typically targeted through the electrification and energy management in fleet and real estate. Those are Verizon's two big buckets. Scope 2 is typically targeted through renewable energy procurement that includes renewable energy attributes. So that's really important what Matt said. It has to include the renewable energy certificate, or globally they call it different things. Scopes 1 and 2 reductions at a company often result in Scopes 3 reduction at another company. So that's why it's important for big companies like Verizon to set Scope 3 targets in order to incentivize our supply chain partners to decarbonize their own operations. So corporate sustainability commitments reflect a company's value and its will of its customers, employees, and investors. They're typically oriented around either emissions or specific renewable energy procurement targets. So I'll talk through Verizon's goals, which are broken down into both emissions, and then we have specific ones broken out for renewable energy. So the most broad objective is the first bullet here, which is a net zero operational emissions, Scope 1 and Scope 2, by 2035, with an interim target of 53% reduction by 2030. One of the organizations that Matt mentioned before is SBTI. Both of these goals were developed with and approved by the Science Based Target Initiative, which also helps us to validate our progress towards them. For scope 3, Verizon expects to achieve 40% reduction by 2035, which is also in line with SBTI guidance. So it shows the importance of some of these NGOs in helping big corporations like Verizon develop our emissions targets. Now, looking specifically at renewable energy, Verizon plans to achieve 100% renewable energy by 2030 with an interim target of 50% by 2025. So it gives us a little bit of a runway to get to 100%. In addition, not shown on this slide, but we have a 24 megawatts of on-site solar goal by 2025, which I'll talk a lot about today. So if you could advance to the next slide, Matt. Thanks. Verizon's decarbonization strategy reflects our emissions profile. Industrials, retailers, and pharmaceuticals will have very different strategies depending on their own supply chain emissions. This slide outlines some of the work that Verizon is doing to reduce emissions across scopes 1, 2, and 3. It's going to be pretty typical, I think, across similar organizations, but everyone's going to be a little different. Most of Verizon's scope 1 emissions come from our fleet of approximately 20,000 vehicles and our portfolio of about 100 million square feet of real estate. So, big operational footprint, and it's really down to fuel and natural gas used to heat our buildings. Jumping all the way to the right-hand side of the slide, for scope 3, our most material categories are called purchase goods and services, which comes from the goods that we use, to power our network, and then use of sold products, which is the emissions that are resulting from the use of our products once they hit a customer's hand. So to mitigate both of these, we're working on to mitigate the downstream effect, we're working with the suppliers to make sure that the products that we sell to our consumers have energy efficiency standards. Today, though, for today's discussion, we're really just going to focus on the middle of that. So scope 2, specifically within renewable energy procurement. Just keep in mind that renewable energy is only one piece of the overall picture that also includes things like energy efficiency and electrification. So for scope 2 emissions, as of February 2024, we had in place 27 renewable energy purchase agreements, so vPPAs worth they combined to a total of 3.6 gigawatts of anticipated generation by the time that they come online. So you'll notice I'm being very careful with my words. All of this is, I see Matt smiling. The way that commitments are communicated to external stakeholders is very, very specific. And depending on how you structure your agreements, what attributes you're retiring in your name, you have to be, there are rules around what you can and cannot say. So I think more on that later. Since 2013, Verizon has also developed 37 megawatts of on-site green energy that's currently in operation. So this is a mix of solar and fuel cell. On the load side, we have a building strategic decarbonization initiative for large buildings that focuses on LED lighting, electrification, building management systems, and then decommissioning of legacy telecom equipment. And then above all of this, to fund this work, we have issued $6 billion in green bonds, making Verizon one of the largest corporate issuers of green bonds in the world. So really impressive work all around. And throughout this presentation, I will always point you back to our 2023 ESG report, which was just published about 2 weeks ago. Okay, so we'll jump to the next slide. So in my time at Verizon, I've been involved in about a dozen large-scale commercial projects ranging from 500 kilowatts all the way up through 5 megawatts. In this section, I'll give an overview of the 3 main formats of on-site solar, talk about some of the advantages and disadvantages of all of them. We'll discuss a typical project flow, and then we'll wrap it up with a very quick discussion on some financing options. So if you could advance to the next one. Thanks. So why on-site solar? And I put here energized buildings and people. Solar is very visible, and it makes a really tangible commitment to your stakeholders that that shows that your company is invested in renewable energy and potentially can provide a return on investment. So this picture here is Lake Mary's finance hub. I'm sorry, Verizon's finance hub in Lake Mary, Florida. And at 2.1 megawatts, this is one of the largest behind the meter solar installations in Florida Power and Light territory. So we're really proud of that. Since it was installed in 2021, it's produced about 2/3 of the building's energy consumption. Next slide, please. All right, so I'm gonna take a drink of water. So solar is one form of on-site generation, and it's probably the most popular form of renewable generation that companies can do. There's three main types. There's rooftop, ground mount, and carports, and we'll talk about each one of those. I'd like to benchmark across these. I think everyone's probably pretty familiar with the three different formats. Rooftop is most common, and it can be benchmarked at about $2 a watt installed cost. Ground mount is probably even a little bit more cost effective at about $1.80 a watt. But there's definitely some drawbacks, like it's going to use valuable space that your company owns. Lastly, carport is almost, you have to think of it as a dual use structure, because on cost alone, it's really not competitive, benchmarked around $4 to $6 a watt installed cost, so 2 or 3 times as much as the other two. But as you'll see from some of the images, it really makes a bigger impact to the site. So we'll explore those in the next few slides, where I'll show you some examples of each type installed at a Verizon building. Next slide, please. Thanks. So this is a really great project. This was a site we did down in Temple Terrace, Florida. Big rooftop install over a mixed-use administrative data center facility at 2 megawatts DC. This was one of the largest net meter installs in TECO territory. With 5,600 solar panels, and it's really striking when you're up on the roof looking out over this install how big it is. A few key things. I'll throw out just some factoids about each one of these projects. This project did not have any roof penetrations at all due to the sensitivity of the equipment underneath. We didn't want to make any holes in the roof, so it's considered a fully ballasted system. So it's just weighed down by concrete blocks and considered kind of a floating system. It's Florida. They have hurricanes. This system is rated to 170 miles an hour, and it held up quite well in 2 of the recent storms that they had over the past couple of years. And in the middle of the picture, you'll notice one of the cranes doing a pick. An important part of any rooftop project is a plan for how to get materials to the roof without disrupting site operations. So, lots of good things to talk about here. Next slide, please, Matt. Thanks. So this is a mixed format project we had out in West Sacramento, California. It's a ground mount, and then it's a rooftop if you look on the rooftop of the building in the background. Verizon had some unused land next to one of our existing facilities, so it made for a really good option. Lower cost option and increase the total system capacity. This image here, it's a great example of why you need a good O&M plan that may or may not include a cleaning schedule. This photo was taken right after some of the bad wildfires that they had a couple of years ago in California, and you can see that panels are quite dirty and the production of the system dropped off pretty dramatically. While this site has overall performed very well, it's also a good example of some of the drawbacks, one of which is vandalism. We had a couple instances of theft at this location, as well as people hitting golf balls into our solar panels, cracked panels, things like that. So these are all things that you have to deal with as a project owner that might not show up in the business case and might not show up in your initial plan. Next slide, please, Matt. Thanks. So this is in Piscataway, New Jersey. These are kind of a more traditional carport design. This is in an admin location totaling 1.6 megawatts. Here, the canopies provide some really nice visual interest to the property, and they provide shade for the vehicles that park underneath. It's a good example of how a carport solar project can add practical features beyond just the power generation. For example, in this case, the V-shaped canopies, they control snow and ice, which is a really nice feature to have in the Northeast. The project was done in parallel with a parking lot repaving project, which reduced the total cost of the site work, and it allowed for a much cleaner finished product. So it really, really looks nice. It also allowed us to incorporate drainage subgrade, so all the drainage from the canopies flows underground to a retention basin. We integrated EV charging, security cameras, occupancy sensors, and LED lighting into the design of the panels. Fortunately, the bulk of the construction was done in 2020, so there wasn't anyone on site to deal with. But obviously, anytime you're working in a parking lot, you have to work very closely with the site operations team and make sure that there's a parking plan in place. Next slide, please. All right, so this is the last project I'll highlight that's kind of a variation on solar carports. This is a 1.9 megawatt garage top system right at the building I'm sitting in right now in Basking Ridge, New Jersey. It's our world headquarters. Our CEO has a location here, and this building is frequented by all sorts of very important stakeholders to the company. So because of that, visibility and aesthetics were really a top consideration. It was important to showcase Verizon's commitment to renewable energy to any of the stakeholders that were visiting this property. So this is called a garage top or long span format, and it has a lot of advantages and disadvantages. So we'll talk through some of those. Number one, it has the highest energy density out of any of the different formats because you're covering 100% of the available area. So you can really pack a lot of generation capacity into a relatively small location. Carports give you a lot of flexibility to integrate water management, lighting, security, etc. And they do have a lot of design flexibility as well. In this location, we included a 14-foot cantilever into the design, and we also did it's called the W-style racking. So we increased the overall system capacity dramatically. So we're really fitting 1.9 megawatts into a really tight space. So overall, really good use of the space. One drawback to this type of system is that you have to, zoning and permitting is typically pretty challenging. But then also you need to consult with your local emergency services to make sure that they have appropriate access. So lots of consideration. Happy to talk through any of the pros and cons of the different designs, but hopefully this gives you a good flavor. All right, I'll talk real quickly about the benefits and drawbacks of each type of system. Some of these are common across the different formats, and then some are unique to the different style. So the main benefit of on-site solar is that you're directly avoiding the energy consumption from the electricity. It's not only saving costs, but it's providing a really compelling sustainability story to the building's occupants and to your investors. There's also really powerful economic incentives depending on the location. There's state and federal incentives, utility rebates, lots of good incentives to help promote a project. The biggest drawback, I think, in my experience, is that these are big construction projects and they typically involve activities outside of a company's core competency. So most companies do not have teams that are built to do this. They need to be stood up everywhere from supply chain sourcing to O&M. You really need to build an entire team in some cases, especially if you plan to own the project and operate it yourself. Let me touch real quickly on some of the individual ones. So rooftop, I would say, is kind of the easiest. in most cases. They can be very economical. They're quick to build, quick to design, and they typically don't disrupt normal operations of the building. However, some of the big things you got to think about with rooftop is the age and condition of a roof can derail the project. It can cost equally as much to replace the roof or more as it does to install solar. Company constraints, especially at Verizon, around roof penetrations and setbacks can reduce the system size. So it might not pan out exactly like it did in the initial conceptual designs. For ground mount's a good option, but it's probably not going to be that common because most companies just don't have a lot of available space. And when you do use that space, it's potentially valuable. Most corporations headquarters are typically in pretty high cost areas, so companies usually have a more valuable use of that space in mind. The additional thing, like I mentioned, vandalism, security is important, and then zoning approval is likely needed, which can be a complex process, as I have found out. Carports, like I said, they're by far the most expensive, but you really have to look at them as dual use structures. They provide a lot of benefits and have a ton of impact, ton of visibility. So you can't really compare apples to apples. You really have to look at carports as a separate style project. Next slide, Matt. All right, so now I'll talk about the project timeline and flow. I can see I'm running out of time here, so I'll fly through this here pretty quickly. But I broke this out into which party is leading. So it's not necessarily that both parties are not involved. It's really who's quarterbacking the project at any given point. So site selection is really important. It's really a function of what goals your company has for that project, whether it be cost savings, visibility, emission reduction. Real estate portfolio strategy is a big one, whether or not you're going to be hanging on to that building long term. And most importantly, I think, is project feasibility. It's, does it look like it's going to be a good application for solar? Vendor selection will also vary company to company. The way I have it laid out here is kind of like, they call it like the turnkey model, where you select one vendor and they carry you through the whole process. There's also a design build model where you have a different firm doing design and construction. So that would look a little different. Let's see. So vendor selection also includes contracting, which is very important and can take a considerable amount of time. But it's really important to protect you legally in case anything goes south down the road. Due diligence is a relatively quick process. That's the next stage here. It's where you go out and you do your initial checks to confirm that the building actually looks as good as you thought it did on paper when you did site selection. Design and permitting is probably, I would say, the longest step of this process and definitely the most variable. There's probably going to be multiple iterations back and forth with the authority having jurisdiction, or AHJ, to make sure that the project meets all local code requirements and zoning requirements. This step also includes the interconnection application, which is really your request from the utility to build that site and to be able to connect it to the local utility grid. Procurement and construction, this is the most exciting part, and hopefully you've done your homework and prepped, because it does go quickly throughout this process. It's really important to maintain good communication with all your stakeholders. And then finally, interconnection. I put some question marks there for how long interconnection takes, because I've seen it take anywhere from 2 weeks to 18 months. We're still waiting for one project to get interconnected that was completed close to 18 months ago. And unfortunately, it's not becoming easier. So hopefully that gives you a good idea of the project flow and timeline. Really 6 months to all the way up to 2 years to, from initial stages of planning to final interconnection. Next slide, Matt. All right, so in this final slide, I'll talk about project financing. I'll just briefly touch on these. Solar projects, it's important to remember that in general, about 90% of the cost of a solar project is going to be front loaded. So the capital structure and the ownership structure is very, very important to getting an on-site project built. On this slide, PPAs and the ownership model are probably the most common, but I threw a couple others on here to cover the whole spectrum of options that you have. PPAs provide a very attractive offer for some companies because they are capital light. So they're really no money up front. And you do get some savings in an ongoing basis. However, the treatment of the RECs should be carefully considered because it will affect the sustainability claims that could be made. For example, like Matt said, you can have solar on your own roof and not be able to claim use of renewable energy. Leases are less common, but maybe the best option in certain situations where budget stability is preferred. Ownership is the next model. Verizon has has a lot of experience with the direct ownership model. It has the highest ROI, but is also the most hands-on. It requires customer attention throughout the entire life cycle of the project to make sure that it's operating well. Land lease is a good way. It's probably a lot less common, but it's a good way to support the use of renewable energy on company land if you don't have the resources or the load to support an on-site project. And then the last item I'll spend just a minute touching on. It's a growing segment that relies on state legislation to implement a regulatory framework to facilitate transactions between developers and utility customers. These projects are a really great way to share in the benefits of on-site solar with the local community, even if you might be resource constrained or might not have the best location for on-site development. Another benefit of these programs is that they often come with guaranteed utility bill savings, while most do not come with a sustainability claim. So again, you have to be very careful about how you claim the use of that power. And then they are geographically constrained. So 20 states currently have community solar legislation in various stages of development. So there's definitely you are limited to the geography in which you can participate in these types of programs. So we went through that quickly. I'm happy to answer any questions. Hopefully, you got a good summary of what a corporate on-site renewable program would look like. If you're curious to learn more, I will absolutely always point you back to ESG reports. Just about every company these days publishes one, and most of them just came out over the last month or so. So they're great places to learn about the goals, the progress, the way that companies message their sustainability objectives. Happy to answer questions at the end, but now I'm going to turn it back to Matt to discuss the really important topic of virtual power purchase agreements. So back to you, Matt.
Thanks, Mike. That was great. So I'm going to talk about power purchase agreements, specifically virtual power purchase agreements. A lot of the options we've talked about here are very tangible. They're close to the site or on the site. Virtual power purchase agreements are considered off-site transactions. The reason being, it allows corporates or other voluntary participants to go out and work directly with utility scale developers and bring utility scale renewables onto the grid, and then apply those RECs to their portfolio across the US or Canada, if we're talking about North America. Before we, this is the kind of how they work, but before we get into the weeds here, I do want to talk about why they exist. When a developer, greenfields, is starting to develop a project in Texas, Nebraska, Pennsylvania, California, they need to go out and get a lot of cash, a lot of capital. These projects cost hundreds of millions of dollars. And the folks lending them the hundreds of millions of dollars want to know how they're going to get paid back. The simple answer is we're going to sell electricity into the grid, and that money is going to then pay back our lenders. Unfortunately, electricity markets are incredibly volatile. Right now, gas is really cheap. Despite inflation being high, gas is really low, which means power prices are low. And lenders are aware of that, and they don't want to be exposed to that kind of a market risk. So what lenders say is, hey, developer, go out and get somebody to guarantee your returns, and then we'll give you the money. And that's where a PPA comes in place. It was developed essentially in concert between lenders, developers, and a little bit with corporates, but really they needed it, so they developed it. But what a PPA is, a vPPA contract, it's a financial agreement. This is not a power contract. And what it is a corporate will come in and guarantee a fixed rate or a strike price for every megawatt hour of electricity generated from a project. And they will say, we're going to guarantee that rate for 10 to 20 years. Once they've inked that contract with the developer can go out, get financing, come back and build their facility. So the mechanics, the way it works is once that's built, the wind farm or solar farm is going to generate electricity and sell that electricity into the grid at whatever the wholesale price is. Electricity in these deregulated wholesale markets fluctuates all the time, but they're just going to sell it as it's generated. This is where the PPA kicks in. For every megawatt hour generated, the buyer, the corporate, the voluntary person, whoever, is going to pay the developer a fixed price of electricity. Let's say it's $50 every megawatt hour generated. That developer gets $50 per megawatt hour every time. The other side is the buyer receives the floating price. So they're going to pay them the fixed price and receive that market risk floating price. At the same time, they're also receiving a REC for every megawatt hour generated off the project, which is kind of what brings them to the table. We get our renewable energy claims, and we're dealing with this complex financial transaction on the side. Throughout this entire process, the buyer, the corporate, is still out there working with their utility, getting power the same way they were. They're still getting invoices from the utility. They're not receiving any electricity from this agreement. It is just a financial contract. So I mentioned that there is this like cash flow, you're receiving the floating price, you're giving a fixed price. I want to talk about that a little bit more. This chart on the right should start to highlight that. Let's say your fixed price is $50 per megawatt hour, strike price, contract price, whatever it is. When the wholesale market jumps up, let's say you're in the middle of the day, it's a hot day, electricity all comes online, electricity prices start to go up. If electricity price in the wholesale market is $60 and your fixed price is $50, the developer actually cuts a check for $10 to the buyer along with those RECs. Now the opposite can happen. Electricity can dip, wind comes online all at the same time, prices start to drop. Let's say the market price is $30 a megawatt hour. At this point, the buyer then has to pay the developer the difference, $20, and then they will still receive the REC. But these are legally swaps. It's a whole nother conversation, probably for more business focused, but these are complex financial arrangements. They are not actually settling for every single megawatt hour. What happens is at the end of every month, the developer will total every single megawatt hour generated, what they receive from the market, and they're going to send an invoice or a check to the buyer. These are also unit contingent, so they are only in effect when the asset is generating electricity. If a PPA is signed, a wind farm gets built, and the wind just stops blowing, there will be no RECs generated and no cash exchanged. So these are completely dependent on when that asset is generating. One other note I do want to make is that these do provide some sort of hedge effects. I want to be clear, these are not hedges, but they do provide a lot of hedge effects for buyers. For example, if a company has operations in Texas and they don't want to deal with the floating price and their utility bills changing every month, every year, they can enter into one of these agreements, and as electricity prices go up and they see their facilities' bills go up, they're actually going to receive cash from this transaction because they're getting that wholesale price as part of their payment. The opposite happens. Electricity prices go down and their bills go down. They also are paying more as part of this PPA. So it does provide some ballast for corporates and their electricity spend. But that is kind of an adjacent value, a lot more nuance there than we're going to get into today. So where can you transact? In order to transact with a PPA, it can only be done in a deregulated wholesale market. You see the graph or the map on the left? These are deregulated wholesale markets. You've got California and CAISO. Texas ERCOT, the Midwest with SPP and MISO in orange and yellow. PJM is green, New York, and New England, blue and purple. Those are the only markets in which a PPA can exist, or a vPPA can exist and transact. There are also PPAs in the utility space, but that is not something that is part of a regulated side that's not going to be voluntary. I do want to make a note, companies can actually receive power from these agreements. It's a very narrow scope and it's a very specific application. Companies need a deregulated wholesale market in order to transact with the developer, and they also need a deregulated retail market in order to sleeve or wheel that power to their facility. So this really only happens in Texas, Illinois, Ohio, and Pennsylvania. Or that's where we see them happen most frequently. Okay, so the chart on the right, the box and whisker chart, is PPA prices. I want to talk through a couple kind of key points here. First being, you'll notice, so just to talk through what a box and whisker chart is, if you're not familiar, the whiskers on the top and bottom are going to be the highest price and the lowest price. Sorry, let me step back even more. Trio, every quarter my company goes out to the market and we get bids from every developer that we work with, most of the developers in the space. We cobble together all that information and share it with the market because we're nice and we want to share this information so people understand what's going on in this space. So the box and whisker chart, top whiskers the highest price, lowest whiskers lowest price, but the lit up area in the middle in yellow or blue is going to be that median 50%. You'll see that ERCOT in the far left has really low prices and PJM on the far right has pretty high prices. That's not because panels are more expensive in Pennsylvania than they are in Texas. It's because there's a lot of other underlying things that drive these prices. The big ones being the cost to develop, the cost of land, and the cost to interconnect. In Texas, those are pretty low, and in Pennsylvania, land interconnection permitting is pretty challenging. And actually a bigger component is resources. One panel in Texas, there's a lot more sun in Texas, one panel in Texas is going to generate more megawatt hours per panel than it will in Pennsylvania over the course of the year. That's just where the sun shines, how much solar resources or wind resources there are. And because of that, you can actually charge less in Texas because you're generating more megawatt hours than you can in Pennsylvania, where you need to make more money per megawatt hour in order to make your money back for your lenders. So that's kind of the big difference in these kind of pricing, why it's different across the board. Another note I want to make is this is not the be-all end-all price. Like I mentioned earlier, vPPAs have two components, the fixed price that's paid by the developer and the floating price that the market pays and essentially is given back to the buyer. That floating price payment is really important. In some markets, that wholesale market price might be really low. If you look in places like Kansas and Nebraska where you have a ton of wind, if you have a PPA with a wind project in those states, you're likely seeing really low prices because all of that wind's coming online at the same time. There's not a ton of load centers, and so prices end up getting suppressed when those assets are generating. That's opposed to places, if you were to be able to get a solar farm outside of Houston, you might be in pretty good shape. A lot of load can be really high prices in the summer because there's not a ton of solar quite yet. And so you're able to kind of collect more from the market than you are in some of the other states. So when we work with companies that are looking at doing these, we look at both what these PPAs cost, as well as what the wholesale market's doing when these assets would be generating. So it's not a simple thing. There's a lot of complex financial modeling going on. But yeah, those are the two kind of big important price components. So why do companies do these PPAs? A big reason, they can lock up long-term RECs. You get renewable energy over the course of 10 to 15 years, and you don't have to worry about prices going through the roof because there's not enough RECs for every company who wants to buy them. Also, really strong renewable claims. I've seen companies actually get naming rights to entire wind farms. They can say, this is our wind farm in the middle of Texas. They can point to a project, they can advertise that project, and they get to claim additionality. They brought that project online. I mentioned hedging effects, but there are also some downsides here. One, these are really complex. These agreements can be 70+ pages of really detailed commercial and legal terms. A lot of times these need to be approved by executives, whether it's a CFO or a CEO or a COO. And they can take 6 months to negotiate or even longer, depending on what's going on. This also exposes companies to the energy market, which is not something a lot of companies like to do. It's not part of their core business. And then the last piece, right now, these are cost additive. This is one of the most expensive ways to procure renewables at the moment. Over the last few years, inflation has driven up the cost of construction, materials, steel, everything that goes into building these systems. But we haven't seen the same impact of inflation on electricity prices. So while PPA prices, these strike prices have gone up, the money that corporates are getting from the wholesale market has not. I mean, gas is really low, electricity is cheap right now. And so that mismatch has actually kind of driven up the implied value of these, or implied cost of these contracts. All right, I know we're at time, Rudy. Should we go to questions? I can just leave this up.
No, please go ahead. No,
okay.
Take your time.
Yeah, quick review.
Finish your talk.
This is everything we talked about today. Just kind of pros and cons. Again, unbundled RECs, going out in the market and buying certificates, really inexpensive, but really poor claims, but can be scalable. You can go up and buy a lot of RECs unbundled. Utility programs and community solar, really specific to your site, may provide you some economic benefit, but really difficult to scale because you have to do it per site, per location, and it's completely dependent on where you're located. On-site solar, economics vary, but we are seeing a lot of projects in the market right now pencil out positively, pencil out well. Unfortunately, great visibility, great impact, and great claims. Unfortunately, it's just difficult to scale. I mean, I think Verizon's done an incredible job with what Mike was talking about, getting pretty large systems. But even that, it's really hard to offset with how companies are run these days with high tech loads, high electrical loads, to actually offset all of their energy with onsite. And then the last one, offsite renewables, we just talked about this, PPAs or vPPAs. These are going to be expensive right now, but they're really scalable, allow companies to really protect themselves over time. And they give you good claims. You get a point to a project, you have additionality, all these good things. The last column in there, direct investments, fairly new. We're talking transferable tax credits. It's we're not going to jump into it today, but if you have questions, I'm happy to answer them on equity investors or tax credits. So with that, I think we are open for questions. Thanks all.
Okay. Great talk. Great talk. All right. So as we've done in the past, I'd like to have, if you want, you can stop sharing screen so we
Sure.
can have.
Yeah. There we go.
Wonderful. All right. So I'm going to ask questions from students first. So students, you know the drill. Please unmute yourself and introduce yourself before asking the question. Question for Matt and Mike. Spencer, you have a question? Sorry. Question?
Yeah, I got one for Michael. Hey, my name's Alex Romanowski, master student in the Energy Systems Engineering program. Have you seen it to be economically advantageous to add battery storage to any of the Verizon buildings to lower peak demand, or is it mostly on the buildings that you're installing solar? Just keeping solar installed.
Yeah, hey Alex, thanks for the question. Really good question. We've looked at battery storage in a number of locations. We are continuing to actively look into it, to research it. There's a few things that have stood in our way. I'll just say broadly, in general, we have not really seen battery storage pan out. That might be unique to Verizon because the load factors of our buildings are very, very high. So we don't, and in general, like Matt said, our buildings are so electrically heavy that in almost every single circumstance, we're never going to export power to the grid. So battery storage in our case hasn't really panned out. But another thing I'll touch on there is that a lot of the buildings that we operate in has tons of technical equipment, very, very high reliability requirements. And so far, we haven't been able to convince internal teams that, you know, lithium-ion battery storage is a good option, you know, for example, in like buildings in New York City or in densely populated areas where we might not be able to put it outside. So there's a handful of things working against us, but the short answer to your question, I think, is to this point, we have not done it. And for a company like Verizon, it has not penciled out for us. But that's, you know, not saying that every single company is going to have the same answer.
Yeah. And Alex, I've actually seen some companies look at it for very specific circumstances, and it's usually less for flattening out their demand and more for capitalizing on utility incentives or managing load factor, you know, other elements that aren't as they're not as simple applications. They're usually very specific, complex applications, what I've usually seen.
So for managing load factor, how would that differ from demand management?
So in Texas, they call it the 3 or 4 Ps. You essentially get your T&D rate fixed every year based on your peak in 3 different months or 4 different months. Would have to go back and double check. But I've seen battery deployment by companies just to game that one system. They're going to use these batteries. They're going to curtail as much as they can. They're going to bring down their load on days they know they're going to get, you know, tagged or checked. And so for the rest of the year, they're not charged for this high load factor they may have or low load factor they may have. And so they're really used very specific to how those utilities operate, as opposed to saying, hey, every day we want to manage our noon load.
Gotcha. Yeah, I guess. Is there a difference in your mind between that load factor and the peak demand management? Because that's normally I lump those two together.
Yeah, I guess they're pretty similar. I think what I found is just like the regular operation. They can essentially take these batteries offline once they've hit their, you know, once they've made their money for the year on that load factor change. So it's difference from like a regular cadence, and we're really going to deploy this in a very specific circumstance. But you're right, they're very, very similar. It's just you're not seeing it run every day to manage peak load.
Have you guys given any thought to long duration storage? And, you know, I'm aware of there's a advanced clean energy RFI right now being run by Google and Microsoft, I believe Nucor. And just curious if you know, you've seen other interest in the market as a reaction to that, and how things like long duration storage might play into kind of long-term resiliency priorities.
You want to take that one, Matt?
Sure. So from where I'm sitting, we don't see a lot of corporates transacting with batteries in that way, particularly because the contracts would be really difficult to manage, and it doesn't really provide renewable electricity to my clients, right? You're taking any electricity from the grid, and you're using it to balance out the grid. We are tracking batteries in markets like Texas, where there are incentives for deploying this, because there are companies that are interested in everything electricity. How can they make money, and how can they participate in the grid? As of right now, there's a lot of risk there between how are these batteries actually going to last over time, as well as what are the regulations around them. They've changed just over the last year and a half. And so I'm not seeing a lot of my clients transacting here. That's not to say there's not a lot of activity in the space. I'm just not involved in any of that. Mike, anything to add?
No, I think you alluded to it. There's a lot of risk and uncertainty. I think everyone is following it very, very closely, but outside of the Googles and the Microsofts, you're not really seeing much action. Companies aren't willing to make a significant investment or sign up for a significant long-term contract unless they have a good understanding that the technology is viable and is useful and valuable in the future.
Thanks, guys.
Question from Matt or Mike?
I see there's a question in the chat. Info on RECs. So RECs have a lifespan of about 18 months. A REC generated within 1 year needs to be retired within that year, but they are also given a little leeway. I think it's 6 years in arrear, or 6 months in arrears, and 3 years ahead forward. And I could have that backwards. When you're talking about 3, 5, or different year lifespans, usually those are long-term REC strips. That's what we would call them. And you're just working with a REC supplier, whether it's a trader, a broker, or a project owner, to buy RECs for that span. I would say that 3, 5 years is usually the longest we're seeing folks transact, because developers are comfortable, or traders are comfortable pricing them. And usually you have to expend those, you're buying those RECs just at that fixed price every year that you are signed up to buy them. Yeah, and that makes sense if you're trying to comply with an RPS. Locking in a long-term strip or a 2-3 year strip is pretty common, because you don't want to be exposed every year to these floating price payments. You want to have some sort of a budget certainty when you're going out to buy these.
Questions for Spencer? You had a question?
Yeah, I was curious about the carport over at the garage at the Verizon headquarters. Is there an increased maintenance cost? Like, is it harder to do maintenance since it's all one sheet?
Yeah, that's a really good question. The ongoing maintenance aspect of it. You'll see some of the designs, like SunPower, who's now owned by Total. They did a number of designs that left every 1 out of every 30 panels or something like that. They would leave it open so that you had an access port to the top. The specific design we used in Basking Ridge, you can remove the panels pretty easily. So if you do need to access the top for any reason, you can get to it. One thing about the cleaning I did mention in the presentation is not every geography by the manufacturer's recommendation needs cleaning. Outside of California, really, like on the East Coast, you're not going to need annual cleaning. I mean, you might need circumstantial cleaning, but there really shouldn't be a good reason to get up there on a regular basis. So it doesn't become a huge problem, but if you do need to get up there, the panels, the racking mechanisms, you can disconnect from the bottom and flip the panel up to get access.
So Spencer, was your question answered?
Oh, yes, thank you.
Okay, all right.
Sure.
Questions for Matt and Mike? I'll open it up to any industry folks too. Use the audio, use the chat box. So Matt, tell me a typical scenario where a utility approaches you, and what do you normally do to make this happen for them? They want renewables, and take it from there.
So our clients are going to be corporates, Fortune 500 companies, et cetera. And when they want renewables, we'll start to work with them, and we essentially start with, what's your goal? What are your risk tolerances? Some companies will say these certain things are completely out of hand. Hey, we lease all of our buildings. We can't do anything on site. because of our accounting structure, we can't do a PPA. So we help them kind of pre-vet all of their options, and then we help them go out to RFP and transact. RFPing for everything from RECs, on-site solar, green tariffs and community solar, as well as PPAs and vPPAs. And it's essentially the service we provide is we help them vet these programs. Are these things going to get built? We don't want companies transacting with kind of new developers who are going to get tripped upon an easy hurdle. Are these going to perform well? And then we help them do all the financial modeling. Are you going to make money? Are you going to cost? What is it going to cost you? How do you get these approved? And then my role is to help educate the organization and get all the approvals that are needed. Depending on what the cost looks like, what these contracts look like, sometimes whoever we're working with in procurement can sign off on them. Sometimes this does have to go up to more executive levels. But our goal is to help them both put together a strategy and then go implement that renewable strategy.
Yeah. So as in your, you talked about on-site generation, and Fortune 500 companies are the kind of likely candidates. So I assume Verizon was one of your clients once upon a time? No?
Not for on-site. We have worked together, but no, not for on-site.
Okay.
I don't think. I came to this new company about 1.5 years ago. So
there's another question in the chat. Sajad Al-Shamari asks, what about battery lifetime?
Oh,
unsure. Mike?
Yeah,
Sure.
again, I would put that in the category of we're watching it very closely. I can't really speak to it too much because we haven't done much activity in that space.
Yeah. And to be fair, like when we're talking about even solar and wind projects, we have ideas of how solar panels degrade and what wind turbines can do over time. But we are right now finding out what's happening to projects that are 20 years old. I know about 1 year ago, it became a really hot topic of how are we recycling wind turbines and wind blades and the nacelles and the whole thing. Because we are just now getting to the point where we're getting to the end of the useful life of some of these systems. So batteries are even newer. The technology is changing constantly. I don't know if someone tells you they know how long their battery is going to last, I would be hesitant to trust them.
Interesting.
Well, another point about batteries, how do you credential it to being green?
Right. And that's a conversation we keep having. Some of our clients are transacting in, PV plus storage systems in Texas. And how you operate that battery really matters. Are you actually doing it behind the fence, or are you tying it into the grid, and are you using the grid to charge your battery? Second you do that, it's brown power, right? It's not a renewable energy system. You're getting brown power from the grid and it doesn't count. Yeah, there's a lot of questions around batteries, particularly in this space. How are they included? How do you manage? Where do they fit, really? Because so much of a battery is a technological play from a utility perspective and a financial play from a lot of developers' perspectives. There really isn't, it doesn't fit well in the sustainability kind of conversation.
Mm-hmm. A couple interesting points on that topic, though, Rudy. There are some interesting initiatives, especially going on in New York City. I mentioned community solar. There's also community battery storage, where, similar concept, they actually operate under the same regulatory framework that community solar operates under. Where, basically, if you can't install battery storage at your facility, you can contract with one of these companies and they will buy energy when it's either cheap or lower carbon, and then emit that energy to the grid when it's higher carbon or more expensive. You have to optimize between those two factors, which may or may not be exactly the same. So the reporting of battery storage is very complicated. We've brought this to our sustainability team, and there's a lot of questions. Their first question was the scope 3 impacts, upstream and downstream of battery storage. Because anytime we mention batteries, lithium mining comes up, life cycle emissions. So there are a lot of question marks around batteries right now, and we have chosen not to play in the space too actively because for us, at least, again, the value proposition was not there, and it's certainly not enough to make it compelling enough in order to deal with all of these questions that we've been getting. So yeah, I think more to come on batteries. But Matt mentioned the Texas market. If any market is going to take off, I think it will be Texas because of the variability in price and general instability of the ERCOT market. Texas is the giant petri dish for electricity markets around the country. So I think they're going to happen there first.
There is actually a huge
Yeah,
backlog of storage projects in Texas. So they are coming.
Yep.
I don't have a ton of insight because that's usually going to be done by utilities or large industrial players doing it financially, not as a corporate sustainability play.
Okay, there's another question in the chat. Larry Cranford asked, for roof-mounted projects, what considerations are made for roof condition and replacement?
Yeah, that's kind of the key thing for roof-mounted projects. There's two key considerations. Your roof is going to have, usually they call it like a TPO membrane. It's the roof material for most commercial buildings. The condition of that roof, those TPO membranes typically have a life cycle of about 20 to 25 years, which is kind of similar to a solar project's life cycle. So, our rule of thumb was that if the roof had not been replaced in the last 10 years, we were not going to do a solar project on that roof unless it was also paired with a roof replacement. Because, the way that the timelines line up, it has to be just about a brand new roof in order to ensure that you're not going to run into issues later down. Because either you're going to, you may end up having to remove the entire solar system just to redo the roof and then reinstalling the solar system. So that's an important factor. Roof penetrations, I mentioned, the sensitivity of the equipment underneath, and a structural analysis of the roof. Obviously, between the solar system and potential snow loads, depending on the geography, you need to make sure that your roof has enough structural capacity to handle the system. Roof penetrations are really important because they weigh a lot less than concrete blocks. And in several cases in our portfolio, we had to decrease the system size because we couldn't do roof penetrations and we had to have fully ballasted systems. So, between the combined weight of the system plus any potential snow load safety factor, we had to reduce the size of the system. So, those are the two main things. It's condition of the membrane and the structural analysis. So did that answer your question?
Larry?
Okay.
Yeah. Yes.
Great. Thanks, Larry.
Okay, questions for Matt and Mike? We've got a few minutes left. So Matt, you talked about virtual power plants. That's an up and coming topic. And will this impact what you're doing for voluntary procurement or for utilities?
Well, virtual power purchase agreements, I think, are a little different than virtual power plants, but that is
I'm sorry.
I don't know.
I'm sorry.
That is a space that corporates do participate in. It is usually less a sustainability play and much more a financial play. Companies that do have variable operations, I mean, this is where batteries in theory could come in down the road. With that directed curtailment, if you have a utility that's particularly in Texas, is I think where we're going to see it. Like Mike said, it's the petri dish for all things energy. When we have these winter spikes in Texas, there are companies who will say, we will just go offline. We're not going to pay $5,000 a megawatt hour. We will just go offline. And I think in Texas, you're going to start seeing companies start doing that more actively, even if it's not to make money, or they could make a little bit of money, but to avoid the cost of these price spikes. And so that, I think, that behavior then lends to, can you sign up to be a virtual power plant? Can you sign up with some sort of consortium to all curtail your load at the same time to essentially like generate electricity or essentially reduce the load? I do think that's happening in Texas. And I think it's hopefully they can figure out how to manage load in other ways. But as of right now, I think, yeah, that is definitely happening. We have clients that are looking at it as well.
Building on that, Matt, I think the type of load that's growing in Texas is mostly data center or cryptocurrency load. Crypto is obviously, there's no reliability requirements for cryptocurrency miners, but obviously it's a relatively simple formula for them. They have input costs. They know what the value of their product is, at least on a daily basis, maybe not long term, but the cost of energy will dictate whether or not they run. They have the ability to turn off their servers whenever they like. Now the data center load has much higher reliability requirements, but is typically also paired with an equal number of backup generation. So, here at Verizon, we have a load curtailment program in some of the northeastern states, which is tapering out because of EPA requirements. But if we get a price signal from PJM or from New York ISO, we do have the ability to turn down some of our data centers, move them over to backup generation for a very small period of time. And then we get load curtailment payments. I see the same thing happening in Texas, given the type of load down there, where the data center with the flip of the switch can turn on 10 megawatts of backup generation and avoid paying $3,000 or $4,000 a megawatt hour. So again, goes back to Texas being a petri dish, but we do have an established program in PJM and New York as well.
I'm going to steal that mic.
One time,
Okay, you got it.
time for one last question. Thank you, Matt and Mike. I think it's so fitting that not only are you past ESE graduates, but it's a great example to our students today as to what are some of the possibilities. And thank you again. And the topic is so vast and so much looking into the future, like looking into the crystal ball.
Yeah.
And I can't think of a better way to finish the semester with this talk. Just to let you know, as part of the student assignments, they have to kind of critique your talk and produce a Zoomcast for 20, 30 minutes. And so we'll discuss that in class. And with your permission, if you're okay with it, we can put it on our YouTube channel once it's complete, for public consumption. So that's what's in the plan. And I'm so glad that we can finish the semester with a bang here. Thank you.
Yeah. Thanks all. Thanks
Thank
for
you
joining.
all.
Great to be back.
And
Thank you.
we'll see you next semester, probably late August or early September start. Thank you again.
Thanks all.
Take care. Thank you.
Bye-bye.
Thank you.